All right. OK, this actually works. Great. Hello, everyone. My name is Joel. I'm one of the creators of Ceramic. And our vision is really to enable the internet to not have siloed data. Because today, a lot of the information that we generate when we interact online is actually locked into different applications and companies. And to do this, we need to make the web composable. So today, I'm going to talk about what composability is and how we can actually make that happen. So what does this problem look like in the first place? And how does it manifest on the traditional web? So this is a personal example where me and my team, we're using Notion to create product roadmaps. We define our projects with scopes and specifications. But Notion is not really great when it comes to like fine-grained like task management and issue tracking. So for that, we use another tool called Linear. But now we have to have and track our projects in these two different applications. And oftentimes, they end up getting pretty out of sync. And this is, of course, a problem. And also, we have to have different accounts to sign into these different applications. So it's just a lot of things to manage. And so how would we go about solving this? Well, the Web 2 approach to this has mainly been to create an API where maybe Linear integrates with Notion or the other way around. And this can kind of work. It can create decent experiences. But if you've been around and saw what happened with Twitter and Facebook, they had these open APIs, and a lot of people were building on them. And then suddenly they got rug pulled, and their entire application that they were building was no longer possible. And so this approach of integrating an API of another company is actually problematic. Another approach could be for one of these applications to just build everything, but then we're kind of centralizing all of that data into one application. So what is composability then? We need this shared state. We need applications to build on the same data and the same kind of state. But we also need to be able to have some kind of permissionless innovation and not have the state be able to be moved away from us. So when we have permissionless access to the state, we actually gain composability. And composability really changes how we build applications. In a traditional Web 2 context, we have a team that generally just builds the backend, builds the frontend, and it's a very tight integrated loop. But in a more open and permissionless ecosystem like Web 3, we actually just have a bunch of different components that may or may not interact, living on a core, open permissionless protocol. And then there might be multiple different product teams that integrate towards these components and only pull in the components that they really care about. And this really enables us to move much faster and have more innovation happening. And so we, of course, have seen this on Ethereum a lot. Ethereum has a lot of composability because we have these tokens. It just enable a huge ecosystem of DeFi, a huge ecosystem of DAOs and coordination tools, a bunch of NFT tooling that's used for art, track real-world assets, and other types of access control. And really, the key thing here is that we have permissionless innovation. If someone deploys a contract, I can rely on that contract being there and not being removed and not being rug pulled of the application that I'm using or that I'm building. But a lot of data in Web 3 is still being siloed. So in particular, this is very visible in the DAO tooling space, where when we do task management, we discuss things on forums and vote and so on, and in off-chain systems, all of the data that we generate as users tend to end up in specific applications. So there's a lot of siloing happening there. In social applications, we actually have some pretty much better Web3 social protocols. And we have some composability within that domain. There are multiple different front ends to some of these protocols. But the data is still kind of only composable within that domain of social applications. And in knowledge graphs and knowledge types of applications, there are more protocols similar to the social ones that allow us to have multiple front ends, but we still have mainly composability within these knowledge apps. And our reputation systems today in Web 3 are mainly using on-chain information, which is quite limiting. What if we could just pull all of this into our reputation? So ideally, we would live in a world like this, where I can start to contribute to a Web3 knowledge graph. And the profile I'm using there is actually my social profile. And as I'm generating useful information, I actually gain reputation based on that. And eventually, there's some DAO that has some decision needs to make that looks at the knowledge that I generated to make that decision. And so this is really what we need and what we deserve with Web3, like have data be composable across all of these domains. Right, so doesn't sign in with Ethereum kind of solve this? If we can just sign in using our Ethereum wallet to everything, don't that mean that everything is now composable? Well, we kind of solve part of the problem. So signing in with Ethereum enables us to have the same account across multiple different applications. And applications can pull in data from an Ethereum to give you access to different things based on your assets. But the data that you generate and gets stored on the application's backends and is still siloed in these different applications. Because we only have shared financial state. So ideally, we could have a system where we store financial state in something like Ethereum, and all of our other user-generated content is actually stored in a separate network. And this would really enable composability. It would allow us to have these application servers to be really thin, or eventually, hopefully, disappear completely. So what would we need to actually create this network that can store all these user-generated content? Well, we need essentially a network for composable data. And to achieve this, all of the data that is generated by the user needs to have authority that's based in the user's account, the user's wallet. And the data needs to be reusable, so I can reuse it across multiple applications. And we need to be able to remix this data if you're not satisfied with kind of how the data was in some other application. And finally, we need this protocol to be web scale. We need to be able to support millions and billions of users. So Ceramic is a protocol that can enable this. And this Tuesday, we announced ComposeDB. So ComposeDB is a graph database that's built on the Ceramic protocol. And it enables developers to create data models that are composable and that you can kind of pick and choose to build into your application. So at the base layer, Ceramic is an event streaming protocol. ComposeDB indexes data, and data models are kind of the interoperability and composability layer. So how does Ceramic enable this? Well, Ceramic at the core is an event streaming protocol where all of the data is stored in a hash-linked event log. And this event log is generated by each user and signed by each user. So we have strong security guarantees because actually we can verify that the user was the one that signed and generated this content. And since every user generates their own event log, we can actually shard and scale this network much more than we can on a blockchain because you separate the users into different components of the network. And then the whole system is anchored into Ethereum for timestamping, which makes it eventually consistent. So you can think of ComposeDB as an architecture like this, where different applications can run ComposeDB nodes, and they basically index different parts of the Ceramic network. So you can think of these puzzle pieces here represent a data model. So maybe this is like these three puzzle pieces are a profile, a blog post, and a comment. And so one application might pull in the blog post and the profile, the other one the blog post and comments, and the third one is like a super application that pulls in all three of these. And as users are interacting with these, data is shared between these applications. So to illustrate that a little bit more, this is kind of what it would look like for an application developer, where a first application might create a proposal data model and use that to have their users create proposals. So here we have like an author and some text. Then application 2 comes along and sees like, yeah, this proposal is great, but we also want our community to be able to discuss these proposals. So we're going to create a comment data model that has a reference to a proposal. And so when application 2 runs this, they can query for proposals and also include all of the comments for these proposals. And the neat thing here is that when this second application creates proposals, they will automatically appear in the first application. And that's how we can achieve composability across these. And reading and writing data in ComposDB is super straightforward using GraphQL. So standard GraphQL queries and standard GraphQL mutations to write data to ComposDB. And there's already a growing data ecosystem on Ceramic. This is 2 different data explorers. One is called SourceScan, the other one is called S3.xyz. And both of them enable you to see the activity and the data is being written to Ceramic. And this is how you would look for data models that might be relevant to your application and see do they actually fit the schema that you're trying to use for your users' data? And do they actually have a lot of adoption, these models that you might pull into your application? And to give you a better idea of what can be built with this, I'm going to highlight some examples from our community. So Orbis is building a Web3 social network that leverages the ComposDB functionality. And not only do they store their data in Ceramic, they also pull in verifications and other types of data from other applications in the Ceramic ecosystem. Lateral is building a decentralized science knowledge graph. And what they're doing is building out this graph of knowledge and information. And since all of the edits to this graph is attributable to an Ethereum address, what they want to do eventually is start rewarding people that meaningfully contribute to this knowledge graph. Daoism System is building something really cool around Gnosis Safe. So if you use Gnosis Safe at some point, you notice that you need to sign multiple transactions to actually make your multisig transaction happen. And these partially signed multisig transactions are stored on the Gnosis Safe centralized server. What Daoism System is, they've created a decentralized alternative to this, where they essentially store these partially signed multisig transactions on ComposDB and enable people to build different types of applications without centralization of these partially signed transactions. And finally, Gitcoin is using Ceramic to create a reputation system to prevent Sybil attacks. All right. Finally, I just wanted to call out that we have 20K in prizes for this hackathon. And we would love to see people build things across these different domains that I mentioned. And also, it would be cool if someone actually composes across different domains. And in particular, if you're building something and you see someone else who's building and using a data model that might be interesting to your application, you can actually just pull in their data model and kind of get part of your application flow created for free. All right. If you want to learn more, join our Discord. We also have a blog and some documentation. Thank you very much.